Hello everyone. This video 3.6 part 1 polynomial inequalities. We will take a look at solving polynomial inequalities and then expressing them as an interval notation. Okay, let's look at the first problem together. So this here we have an inequality of polynomial. So we've had worked with polynomial equations, but because of this inequality, we call this a polynomial inequality. So we're looking for not just one single answer or two answers, we're looking for a range of answers that make this inequality true. So we got 4x squared plus 25x minus 21. And because this is a quadratic polynomial, we're going to start out by trying to factor this expression. So we have 4, and then there's a 4 in front of x squared. So let's go ahead and multiply first and the last terms. 4 times negative 21 gives us, let's see, put it in the negative 84. So this is the term that we are trying to find factors of that will add up to the middle term, which is 25. And looks like, let's see here, I'm going to head over to my calculator again to see what factors of 84 will give us a sum of 25. So I'm heading over to our calculator. I'm already on the y equals screen, and we put in 84 and divide that by x, and then head over to table. We're looking for factors of 84 that potentially add to 25. Okay, it looks like we can work with 3 and 28. Let's head back, 3 and 28. And so our factor of 3 and 28 give us negative 84 because we want to add positive 24. And one of these have to be a negative number. We're going to make the 3 negative. I'm going to show you a different way of factoring, and then we would have written this as 4x squared and 25x, we would write it as minus 3x plus 28x minus 21. And then, of course, we would factor by grouping. I'm going to show you a different method that I was introduced to from a student of mine. Okay, it's the box method. And then how we use a box method, or the reverse box method, is we put each of these 4 terms in these box spaces. So 4x squared, then negative 3x, and then positive 28x minus 21. And you're looking to see what we can factor out from the first column, from 4x squared, and 28x. We can factor out a 4x. And then from the second column, we can factor out a negative 3 from negative 3x and 21. And then what's remaining then in this first row is we can factor out just an x, and then from the second row we can factor out a 7, and then these are then our factors, so 4x minus 3 and the x plus 7. So we have 4x minus 3 and then x plus 7. Now, first thing we need to do is then we're going to just temporarily set these equal to 0. Oops, let me go back. Already in my head, 4x minus 3 equal to 0 and x plus 7 equal to 0. And then we would add 3 here to get x by itself. We got 4x equals to 3. Dividing by 4 gives us x is 3/4. And then here we subtract 7 and x is negative 7. Okay. So I'm going to go ahead and place those values as dots or closed dots at 3/4. And 3/4 is between 0 and 1. So here's 3/4. And also at negative 7. We use closed dots because of this less than or equal to. So less than or equal to, greater than or equal to, you're going to use closed dots or brackets. And then less than or greater than gets open circle or parentheses. Okay, and so we would be done here if this were an equation, but because it's an inequality, now we have to see what are the range of values. There's 3 different regions that we have to test here. The first region is everything to the left of -7. The second region is everything between -7 and 3/7. The third region is 3/7 and bigger. How we test is we pick values, test points that are in those regions, and then to see whether they pass the inequality. So what's less than -7? Well, a test point can be -8, so we'll test -8. And how we test is we substitute it back into the equation and check whether it's less than or equal to 0. So if we plug in -8, we get 4, -8 squared plus 25, -8 minus 21. And what that is equal to, if I put it in my calculator, is I'm getting 35. And 35 is less than or equal to 0. Well, actually, it's not less than or equal to 0, right? It's not less than or equal to 0. It's actually greater than 0. So we say -8 does not. So I'm going to put a big X mark there. That means this region, anything below -7 is not in the solution set. Now let's test a point between -7 and 3/4. The easy point to test is 0. The 0 is always easy to plug in. So we plug in X is 0. And for 0 squared plus 25, 0 minus 21. That's going to give us -21, and that's certainly less than or equal to 0. So 0 works. I'm going to put a check mark above 0. The last region we need to check is anything bigger than 3/4. I should say 1/4. And that's an easy number to test is X equals 1. You could also test X equals 2 or 3 or 4, but 1 is just easy to work with. Okay, so let's plug that into the equation again. So we have 4 parentheses 1 squared plus 25 times 1 minus 21. If we put that in the calculator, I'm getting 8. And that is not less than or equal to 0, right? 8 is bigger than 0. And so 1, the point that we tested, does not work. So I'm going to put a big X mark there. So the only region that worked is between -7 and 3/4. I'm going to put a smiley face there, put a sad face there, and the other regions that did not pass the test. And so what that means is the solution set is the interval between -7 and 3/4 only. Since I'm running out of space, I'll write the solution set here. The solution set is between any value between -7 and 3/4. And we're going to put brackets around the two ends because it was greater than or equal to. Okay, let's go ahead and look at number 2. Number 2 is 16x squared minus 18x plus 1 less than 0. Okay, let's factor this also. And by multiplying 16 times 1, which gives us 16. And then we have to figure out what multiplies 16 but adds to the middle term, -8. I think we can do 4 and 4, and they both have to be negative. So it factors as, I'll do the box method again. 16x squared, the last term, positive 1, and then the negative 4x are going to go in these boxes. Okay, we can factor out from the first column, 16x squared, negative 4x, a positive 4x. From negative 4x and positive 1, the only thing we can factor out is a negative 1. And then from the first row, then this will be 4x. And then we'll factor out negative 1. So 16x squared minus 8x plus 1 factors as 4x minus 1, 4x minus 1. If we set this equal to 0, because it's the same factor, we're only going to set one of these factors equal to 0. We get x is equal to 1/4. Okay, so I'm going to mark 1/4 with a open circle because it's just strictly less than, not less than or equal to. And we have now 2 regions to test. The first region is anything below 1/4. The second region is anything above 1/4. Let's test negative 1. That will be an easy point to test. Test x equals negative 1 by plugging it into the original inequality, 16 negative 1 squared. And then minus 8 times negative 1 plus 1. And I'm actually going to just plug this in to the calculator again. And that'll give me 25, because this is 16 plus 8 plus 1. And 25 is not less than 0, right? You want values to be less than 0. So I'm going to put a sad face there because that region does not pass. And so the other one we want to test is x equals 1. And plug in 16, 1 squared minus 8, 1 plus 1. Here's 16 minus 8 plus 1. That would give us 9. And again, that's not less than 0. And so we put a sad face there because both negative 1 and 1 does not pass. What does that mean? This means that 16x squared minus 8x plus 1 is never going to be less than 0, because if you look at the 1/4, it's an open circle. So even 1/4 is not part of the solution. So for this inequality, the answer is no solution. Okay, let's look at number 3, x minus 1, x plus 4 greater than 0. This is really nice because this is already factored for us. So that means we don't need to do the factoring ourselves, and we can just set each of these factors equal to 0 to get our boundary points. And so x is 1 is a boundary point, x is negative 4 is a boundary point. We're going to do open circles at 1 and negative 4. Notice how now our number line is split up into 3 regions, the first region and the second region and the third region. So we have to test each point or points in that region. Now let's pick a testing point. A testing point can be, we can test negative 5. We can also test, let's do 0. And another region that's greater than 1, we can test 2. Okay. We can do this really quickly using the graphing calculator, and I'll show you how. We can go over to graphing calculator, and we can go to y equals and then type in x parentheses x minus 1 x plus 4. And if we go to table, you can get any values, right? So we had tested or chosen -5. Well, at -5, it's 6. And then the second value we had tested was 0, right? It's -4. And then the test, if we tested 1, it would be 0. Okay, so we have 6, -4, 0. So let me head over back. So plugging in -5 into this function gives you a value of, we said 6. And is that greater than 0? Yes, it's greater than 0. So we say at -5, we're going to put a smiley face in that region. Or you can write yes, that works. When we had tested 0, the y value of the inequality was -4, I believe. And is that greater than 0? That is not greater than 0. So we say, okay, that region is not good. For the last testing value, we had tested x equals 2, and the calculator gave us 6, and 6 is greater than 0. So we say yes. So at 2, the testing value, we're going to put a smiley face. And so if you think about the region, right, that we're going to shade, it's going to be this area and this area. As an interval, the solution set is -infinity all the way to our boundary point -4. We're into parentheses because it's an open circle at -4. And then do union, skip all the way over to 1, and then go all the way to infinity. What that looks like on a calculator. Okay, what that means is if we head over to the calculator and graph this, we're looking to see, let me make it go into standard view. As this is the graph of x - 1, x + 4. We're looking to see where this graph is greater than 0. Greater than 0 means where is it over the x-axis, where the y value is above the x-axis, or greater than 0. Well, it's greater than 0 from negative in this part of the parabola and this part of the parabola. And the left-hand side of the parabola, this is -infinity to -4. And also the right-hand side of the parabola that's above the x-axis is 1 to infinity. So you can also be, instead of just testing values, you can just see as, just look at where the graph is above the x-axis for greater than 0 or below the x-axis for less than 0. Okay, let's go to number 4. We have -9x² - 9x greater than or equal to 0. So let's first try to factor out -9x². -9x has a common factor of -9x. What that leaves inside the factors or parentheses is x + 1. Let's set both of these factors equal to 0 to get our boundary points. -9x is equal to 0 and x + 1 is equal to 0. Here we have divided by -9, which is 0 divided by -9 is 0. And then -1 - 1, x is -1. These are our boundary points. And because it's just greater than or equal to, I'm going to put a closed circle at 0 and at -1. Okay, so now we have to test, there's 3 regions. The first region is anything below -1. Anything between -1 and 0, and then to the right of 0. So the 3 testing test points, we can test -2. We can also test a number between -1 and 0 is -1/2. And then we can also test 1. So you could test any number bigger than 0, but 1 is just easy to work with. I'm going to also just head over to the calculator because it's quicker that way. Okay, we put negative 9x squared minus 9x. You could also graph and see your boundary points this way. It's -1 and 0 because that's where it crosses the x-axis. And I'll head over to the table. Our first boundary point, which we said was -2, was it? Yes, gives us -18. And then our second x value was -1/2. It's not here because the table only gives you intervals of or values of integers. But there's another way we can go around it. But x equals 1 is -18. So to get -1/2, we could actually just go to graph and go to second calc, type in value, and then -1/2. We hit enter, gives us 2.25. So I'm going to try to remember those values, and then let's put it in, head over back to our main page. So when x is -2, it gives us the whole function. The y value was -18. And is that greater than or equal to 0? We say no. So this region is not good. When we plugged in -1/2, that gives us 2.25. And that is greater than or equal to 0. So we say yes, that region works. And for x equals 1, the y value was -18 again, and that is certainly not greater than or equal to 0, so we say no. And so the only region that we can shade in is between -1 and 0, and that interval then is the solution is -1, 0, with brackets around both because of this equal symbol, the greater than or equal to. So remember, greater than or equal to means where is it above the x-axis. And if you look on the graphing calculator, you can see the parabola, this part right here, this bump or hump is above the x-axis between -1 and 0. Okay, we have one more problem to do together. This is a good time to pause the video to see if you can do this one on your own before we look over it together. So this polynomial inequality, x to the third minus 5x squared minus x plus 5 greater than or equal to 0. Again, just 4 terms. Try to factor it. And we can factor it as x squared, x minus 5, minus 1, x plus x minus 5 rather. And then x squared minus 1, we're going to put it again in a factor parentheses. And then x squared minus 1, we can factor it one more time as x minus 1, x plus 1, and the x minus 5. Okay, so we have 3 factors, which we're going to now set equal to 0 to get our boundary points. X equals 1. From x plus 1, we get x is -1. For x minus 5, we get x is equal to 5. So again, it's greater than or equal to, so we're going to put closed circles at 1, -1, and 5. Now, it looks like because there's 3 boundary points, how many regions do we have? We have 4 regions. We have anything below -1. We also have the region between -1 and 1. 1 and 5, and then 5 to infinity. So we have to test 4 testing points. So let's test -2. We can also test 0. So again, you're just plugging in or picking values in any values in that region. We can test x equals 2, and then x equals 6. Actually, instead of 2, let's pick 3. Okay, so using the calculator, I am plugging in -2 into the equation. So plugging -2, you get a y value of -21. And if we ask, is that greater than or equal to 0? Clearly not. We're going to put, that's no good, right? We're going to say no. For -2. For x equals 0, the y value I got was 5. And that is clearly not, no, that is greater than or equal to 0. So we say yes. So we can mark yes in that region. When we use x equals 3, I got -16 by plugging into the calculator again. Is that greater than or equal to 0? Negative numbers are not greater than or equal to 0. So we say no. So actually, let's go ahead and shade that area. Yes. X equals 6 gives us a y value of 35, and that is greater than or equal to 0. So we say yes again. So let's shade in the yes regions and then get our interval solution. So between -1 and 1, bracket -1 and 1, union 5 bracket to infinity is our solution. Okay, so we went over 5 polynomial inequalities together. I believe I forgot to shade this one. The number line is just to help you get the intervals, because with me, I'm more of a visual learner. So the number lines are there to help you shade and then get the interval notation for your solution. This wraps up the section on polynomial inequality. For the next video, we'll take a look at rational inequality. And then I'll see you soon in that video.